Hey, so today what we're gonna do is we're going to take a track and we're gonna take a cart and we're gonna push the spring. It's spring loaded, right? And you're gonna push it in, click, and so this thing is gonna be inside the little spring loaded right there. Load that thing up on the inside of the cart, right? And then we're gonna put another cart right next to it, right? And then what you're going to do is you're going to add some masses to it, to either cart. So for instance, you might add one mass, or you might add two masses, or you might add three masses to the cart, depending on what I asked you to do. And so these masses are added to the top of the cart, and they fit perfectly inside the cart itself. And then what you're going to do is there's a little thing that sticks up right there, and you're going to hit it. And when you hit it, bam, this thing is going to shoot out, right? And the question is, what will the carts do? Is there a pattern to what the carts will do, considering the masses that are in the cart? So a couple of things we want to ask is we want to ask how fast are they going away from each other, and how much mass does each cart have, and then we want to see if we can quantify a total. So we're leading toward cons of mom, the law of conservation of momentum. And let me ask you a question. How much momentum is there before anything happens? So how much momentum is there before anything happens here? You know what I'm saying? Like when it's sitting there on the track and it's not doing anything, how much momentum is there? Then you hit the thing, right? You push down on the little release trigger, and boom, what happens? And how much momentum is there now? So that's the first thing. What is momentum, by the way? So momentum is very easy. Momentum is the letter P, and momentum is measured as mass times velocity. And so how much momentum does a parked truck have? And the answer is none, because it has no velocity. How much inertia does it have? Well, inertia is actually directly related to your mass. That's how hard it is to move. But momentum and inertia, although they're kind of used interchangeable, they're not really the same thing. Inertia is how hard it is to change something, and that is the greater your mass, the harder it is to change. But momentum is how much this physical quantity you have when a mass is moving, m times v. So how much momentum is there? The total system, right? And so remember, we're talking about our system. And our system consists of these two cars. How much momentum is there before you release them? And then how much momentum do they have after? Right? And so that's kind of what we're going to kind of look at on these equations. And then what we'll do is we'll change the amounts of mass in the one cart, or the other cart, I guess you could. And you will kind of compare what happens to these if you change the amount of mass in each cart. And then is there a mathematical relationship between this? Finally, what these are called, what these are referred to, is they're referred to as explosion problems, where two objects will explode away from each other. And it's just a lot like a cannon. And so here's your cannon, right? And a cannonball, right, explodes. They explode away from each other. So they're referred to as explosion equations, but they do fall in the realm of the law of conservation of momentum. And so that's what we're going to try to give a wordle with today. I wonder if my music was totally annoying. I guess we'll see.